Alright, this is our first video in our installment dealing with centripetal acceleration. In this video, we are going to cover our basic equation dealing with centripetal acceleration and how to solve for distances that are traveling in circles and solving more complex problems. To start off, if I'm trying to find the acceleration that any object is going to experience while moving in a circular motion, the equation is just by taking its velocity and squaring it and dividing by the radius of the circle that it's traveling. That's going to be equal to the acceleration that it will experience. When you're driving along in your car and you start to make a turn, you can feel that acceleration. Your body's inertia wants to maintain a straight line path, but the acceleration is actually pulling you inward. We're going to talk more about the inward versus outward feeling. But right now, we're just going to concentrate on our equation that we have right here. So first, let's look at our first problem here. Here I have a car with a forward velocity that is tangent to the direction that I'm traveling in as I'm traveling in a circular motion. So here my center of rotation R, we're going to say that my radius is equal to 20 meters. And then my velocity is just equal to 5 meters per second. So based upon my equation, 5 meters per second squared divided by 20 meters. So 5 squared is 25 divided by 20 gives me an acceleration of 1.25. That's relatively low, so you'd still experience it for sure, but it's nothing that would cause you any difficulty or harm. Let's see what happens if we just double our speed. So if I double my speed from 5 to 10 meters per second. So same equation, 10 squared divided by 20. I get 100 over 20. So now my acceleration is 5 meters per second squared. So that's half of gravity. You would definitely notice that difference. So because velocity is squared over here in my equation, your acceleration that you are going to experience would increase by a factor of 4 by just doubling your velocity. So these are the kind of things that we have to keep in mind when solving these types of problems. Well, let's say we're not given velocity, but we're given other values in order to solve for velocity. Velocity is equal to the change in distance divided by the change in time. What if I'm only given the radius that I travel in and the time interval it takes to do one revolution? So the change in distance divided by the change in time. If I go around one full circle, the circumference of my circle is equal to 2 times pi times the circle's radius. So that would be my change in x. So my change in position is going to be the circumference. So 2 pi, all I need to know is the radius. Now there's a specific word that we call for every time you go around one full revolution. It's called the period. The period equals 1 revolution. So it says if I have a period or make a revolution every 1.43 seconds, I can solve for my velocity. So r over here turns into 2 meters. So 2 times 2, 4. So 4 pi over 1.43 gives me a velocity of 8.78 seconds. So if I'm trying to solve for the acceleration, it's just 8.78 squared divided by my radius of 2 meters gives me an acceleration of 38 meters per second squared. Alright, so we talked about the equation, how doubling velocity is going to quadruple your acceleration. We found another way to solve for velocity while dealing with circles. Velocity is also equal to 2 times pi times the radius divided by t, where t is the period. This equation is not on your equation sheet, but you will need it to solve for velocity. and we can solve for acceleration by just knowing the time interval and the radius as well. Alright, so that's it for our first video.